Welcome to one of the greatest mysteries in particle physics. The mystery is known as a strong CP problem. Strong CP problem. CP means charge parity. So in the study of chromodynamics, chromodynamics means quantum chromodynamics is a branch of particle physics. They are actually particle interactions. Particles means quarks. Interactions between quarks and gluons are studied. So that is the branch of, that is a part of particle physics known as quantum chromodynamics. And there you can find this topic known as a strong CP problem. The first term is what? Strong. This strong term is there due to strong nuclear force. Okay, from strong nuclear force, the first word strong is taken. And name of the problem is what? Strong CP problem, strong charge parity problem. So first let's talk about CP symmetry. Yes, there is one theory in particle physics known as CP symmetry, means charge parity symmetry. According to that theory, if particles are replaced by their antiparticles, then laws of physics will remain unchanged. Okay, will remain unchanged if particles are replaced by antiparticles. For example, you can say like, protons are positively charged. So if positively charged protons are replaced by negatively charged antiprotons, then laws of physics will remain unchanged, means will remain the same. Similarly, if electrons, those are negatively charged. So if electrons are replaced with positrons, in that case also laws of physics will remain unchanged. Okay, so according to CP symmetry, this theory, this is true. Again, if you talk about parity transformation, means if the positions or the coordinates are flipped, coordinates of the particles are flipped, just like mirror image, then also in that case laws of physics will remain unchanged. So this is known as CP symmetry. So this is what? This is theory. After that, experiments were conducted several times by scientists. In case of weak interactions means weak, this term comes from weak nuclear force. Okay, so in case of weak interactions, scientists found the violation of CP symmetry. That means CP symmetry actually is not correct. It is not a correct theory. So in case of weak interactions, scientists found this result. Means they found what? They found violation of CP symmetry. So similarly, we can easily say that in case of strong interactions, in that case also, there should be a violation of CP symmetry. But astonishingly, scientists found that in case of strong interactions, there is no violation of CP symmetry. And one more thing, if CP symmetry were violated during strong interactions, then that would indicate, scientists would get the result of neutrons having a non-zero electric dipole moment. Means neutrons would have a non-zero electric dipole moment if CP symmetry were violated in strong interactions. But scientists have found no such evidence. Okay, scientists have found no such evidence. So that means this is a problem. Since this is a problem, so the name of the problem is given this way, strong CP problem. Okay, strong CP problem. So after that, what happened? After that, scientists started thinking over this problem and they tried to modify the equations of quantum chromodynamics. And accordingly, they included a term known as theta term, which should take care of that problem. But after inclusion of that term, after including that term, again experiments were conducted, and astonishingly, scientists found that the value of theta is either 0 or very close to 0. That means actually presence of theta term makes no meaning. It becomes meaningless. Inclusion of the term theta becomes meaningless. So where is the problem? Then scientists, means from the mind of the scientists, one new idea came. And that idea was the concept of a hypothetical particle known as axion. So Axion could solve this problem known as a strong CP problem. Axion. Again, by using the concept of axion, we can easily, according to scientists, they can easily do what? They can easily know the truth of the universe, the reality of the universe. One of the biggest mysteries in astrophysics or cosmology is what? That is the presence of dark matter. According to the theory, dark matter makes up almost 85% of the universe's mass. So that theory of dark matter could also be explained by the presence of axions. Why axions are being called to be hypothetical? Because still there is no practical evidence of the presence of axions in the universe. For that purpose, they have designed experiments, different experiments. Out of that, I know two names, ADMX and CAST. Two experiments are there. By using those experiments, scientists are trying to find the trace of find the existence of the particle axion. Actually, according to the theory of axion, according to the theory of axions would be converted into photons in the presence of strong magnetic fields. So, in their experiments, they have designed it like this. Means, if in their experimental setup, if axions come in contact with their experimental setup, in that case, those axions would be converted into photons, X-ray photons. And X-ray photons, those things are easily detectable by our instruments. That way we will be able to know the existence of axions. So scientists are trying to find the existence of axions. Anyway, so this was all about today's topic, strong CP problem. So this is what? This is nothing but a puzzle about a missing particle. Missing particle is here axion. And this is puzzle. And if axions are found, then these axions could solve two puzzles simultaneously. One puzzle is related to dark matter, another puzzle is related to strong CP problem. Both the puzzles could be solved simultaneously by the help of this axion. That's why scientists are very interested to find this particle. Anyway, so this was all about today's topic, strong CP problem. So this is the end of this video. Thank you for watching this video.